concept related with the friction and also its application, which is very important in daily life as well as like whenever you have to, let us say for example, we take application of car driving, you should know that at what different locations you are having to the friction and the tires. So let's see it from very basic concept. Friction, to define it, let us take one block and which is resting on a surface like this, and it is having weight W, and one has to apply a load. If you try to draw the free body diagram of this particular object, what will really happen? You will see that we have friction forces acting, normal force acting in this direction, and here it is F. Here we have load W and load here, the applied force. Look at the microscopic view of this contact surfaces, how it really looks like is you have from having very rough surfaces like this, and when you look from the rough surfaces from the block, you will see that things will be this, sometimes this. So in this particular block, that the contact region over here is now converted into the point contact. So if you try to write down the forces over here, you will see that here, like if for writing the forces at the contact point, what you really have to do the surface and now transfer all the forces on this red point, so you will be getting direction, which is 10 1, and since it is moving in the direction of motion in this the opposite directions. So it means that here are the forces that is acting as dF1, and then here you are having things at F1. Similarly, you can write this up to this nth point, and this F. Okay. If you try to write down the forces which are acting in the normal direction and the x direction, ultimately you will end up, that if you do concept, generally you will be getting force, friction force F, which is nothing but. Now if you try to look at this characteristic of friction, so it has mu s, and another one is we have mu k. So mu s is the coefficient of static friction, and mu k is the coefficient of kinetic. Okay. Now the other point is that if we try to draw the characteristics of friction forces versus the applied load P, so P is the applied load, apply this applied load on this particular object, you will see that initially the body, because of the influence of this friction, will not. There will be a point, so this is your friction. There will be a point after which the body starts moving. Static friction. And afterwards, and you will see that, you know, after certain load, let us say, if P is greater than P critical, the friction forces will. And what will be this particular? So this is called your Fs. So up to this point, you will find that there will be no motion of your particle, and in this region you will have motion. However, the friction forces will reduce that, and corresponding to that, kinetic friction force. And as you increase the applied load, this kinetic friction will again become zero, and at very high P, the whole body will just slide, you know, and the friction will. Okay, so this is your, you know, basic concept of a. This is the basic concept of friction. Up to this point, what we remember, and you will see that, you know, this mu s and mu k. So now let's talk about the application of these friction. Although there are many applications, but we will try to, you know, discuss few important ones from the fundamental point. Just write down those points. Application. So application number one that we will discuss is about the wedge application. Second one is your, you know, it's the bearing. Third one is your jack screw or power screw example. Fourth one is your rolling friction. In this, we will see two kinds of things. First one is the journal bearing related friction, and here we will see and or collar bearing kind of example. For example, if you want to understand it a better way, and here point, this surface is being fixed, okay, which is having load W and movement. So when it rotates, you will see that there will be the friction surfaces, like it has to overcome the torque applied by the friction forces at this contact region. all the time we are assuming that there is no friction at these two surfaces. No friction. No friction. Okay, so this is called your and bearing example. And then we have this collar bearing. So in the collar bearing, you will see that how it exists. So contact region is this. So this is an example of, so it means that again it has to, has to take, like, support the axial load as well as it also has to rotate with momentum. Now if you try to, and this is called your collar bearing because it has these collars. If you try to, get the middle type of, inclined kind of bearing, this what really happens. So here you can take the radius as R1, this is R2, and same way here you can assume. So it means that, and these are all fixed. So in this case, you will see that it is just, the inclined kind of bearing. Okay. And again, you will take it as R1 and your theta, and this is also your. So these are the example of, hand and collar kind of bearing. Now there is another example which is called the journal bearing, in which what really happens that the outer casing is fixed and inside you will have a shaft which is rotating. Okay, so in this case, what will happen? Let us say your shaft is rotating in this direction. The ideal condition. The ideal condition of your shaft. This is dotted point is your shaft. And this is your bearing. Now, when it tries to rotate in this direction, what will really happen? You will see that it will climb over here. So it will try to climb, but it is at the same time rotating. So when it climbs, it will come in contact with the surface over here. Shaft fixed over here. Okay. So you can see that before your shaft becomes operational at the steady state, or it becomes free from this particular contact, it has to overcome the friction with the contact of this inner part of this bearing. And what will really happen, we will see that we will have reaction. Since it is direction, this particular in this way, and the normal will be acting in this, right? So what will really happen is since your body is moving, trying to climb up, it means that you will have to take kinetic friction. 5K, which is nothing but tan inverse mu. I will talk about this relationship later. Example of another friction problem. Now power screw is another example, and rolling resistance is another example. Okay, so let's start. So these are some of the applications of your. So let us start with the first. Application number 1, wedge. In this case, what is generally is computed is, let us say you have to raise a block. This kept against a fixed wall. Now you are going to a wedge over here. So let us say that wedge is having an angle is again fixed, okay, and this angle theta. Wedge is having angle theta. For the application of wedge, this theta is generally fixed. Okay. Now you will have to write down. So let us say W is the weight of your this particular block which has to be supported, and you are going to apply a load P. Okay. Now you have to find out the relationship between P and W that it can be raised. Okay, so it means that you have to provide a motion. You have to provide P such that it can be raised the above direction. So what we have to do is we'll have to first draw the FBD. And before that, we also have to point out that how many contact surfaces are there. So let us say this block is A and this wedge is B. Contact surfaces, this is one contact surface, we call it as 1. This is second contact surface, we call it as 2. This is third contact surface, we call it as 3. Now, the number of contact surfaces are 1. So, when we draw the FBD of block A, let's say block A, how it will work out is, so it means since we are applying some load to raise it, so what will really happen? So this is going in this direction, this will go in this direction, this will go up. So if it has to go up, there will be friction in the opposite direction. Means that we will have friction 1 and here normal and 1. Normal from the wall and friction, since it has to go up, so friction is in this direction. To start the upper motion, you have to overcome this load. The similar way, this guy is going inside, So since it is going inside, so there you will have load in that direction. So here this is going up, so this is going, has to go inside. It means that this guy over here. So let us take FBD of block B as well, so that things. Okay. So if you take B point, this is going in this direction. It means that there is a friction in this direction about this. So here you direction which is anti. What will happen at this point? This will be just opposite to the direction of that. So Ft is in this direction. It means that here it will be this direction, because these two are the same contact surfaces. Point 2. Okay, so contact number 1, this is 2. So here again you will be F1, and we know that this is this angle is theta. This way one can write down what is missing over here is, and so this way we can find out, like draw the FBD of these two blocks. Now to find out all these unknowns, and so what you really have to do is, here you have, how many unknowns are there? 1, 2, 3, 4, 5, 6. Theta is known. So it means that how many, if there are these many unknowns, like 1, 2, 3, 4, 5, 6, and this is also an unknown that you are applying. Okay, this is what has to be found. So it means that the number of unknowns are 1, 2, 3, 4, 5, 6, and 7. Right? So number of unknowns are 7. For two blocks, block A and B, how many equilibrium equations still exist? So for block A, you can write either summation of Fi0 and Fy0. Since we are taking no tipping condition, so in that case the moment will not be considered. So you have two equations for block A. For block B, again you will have two equations. It means that you are having just 4 equations and 7 unknowns. So it means that you will have to use certain relationships, since there are 3 contact points. So you require three more equations, and those 3 more equations given by 3 addition. So this will be 4 and 3 additional equation are given by friction, and F1 is equal to mu. Mu s is the coefficient of static friction on all the surfaces, 3 surfaces. They are same, so you can say that F1 mu s is equal to, I said here we are taking mu s1. Yes. Okay. So this way you have 3 more equations. Yes, from here 3 more. So 7 unknowns are 7, and number of equations are 7. So this way we will be able to solve the problem related with the wedge. Now, so how to find out relationship again using all these equations? You will see that. Let us write down basically for all this. So the first, if you write x component over here, so what you will be getting, so here this is your theta is this. So it means that perpendicular to this one and this one, your theta, right? And since this is your f2 is along this direction, so if you write summation of fx for block A, summation of this for block A, it will give you minus n1, right? This will be n2 cos theta, n2 sin theta. So n2 sin theta, right? And this one will be f2 cos theta. f2 cos theta is what? Mu s times n2 cos theta. And that should be equals to 0. So this is your first equations related with this block A. So this turns out to be minus n1 plus n2 sin theta plus mu s cos theta equals to 0. When you write, so this came from fx is equal to 0. If you write fy is equals to 0, what will happen? It will be your n2 cos theta. This one is here, this is at this particular point cos theta. Okay, so this is your cos theta and this will be minus cos theta. So it means that minus f2, so but that is mu s n2 sin theta. And so we have considered these two forces. What about the forces which are coming from here? So here we have minus f1. Minus f1 in a sense that f1 is equals to mu s times n1. So that will become 0. So right now we are having, and the additional thing that is required is, we are also having load W. That needs to be considered to find out things. So your Fy is in the negative direction. So here minus W equals to 0. So this way you will be getting again relationship which is given by n1 minus mu s n1, and if you take common from here n2, that will be cos theta minus mu s sin theta, right, is equals to W. That equation number 1, equation number 2, if you solve simultaneously, you will get the n1 and n2. n1, this will be n2. Okay. After you know n1 and n2, so what will be your n1? Basically, if you substitute your n1, which is nothing but n2 times this one, you will be getting n2 is equals to, write down, n2 is equals to cos theta mu s sin theta. Okay, and on the top having in as here you will be having n1 is equals to n2 sin theta plus mu as cos theta, and then n2 by substituting n1 over here, you will be getting n2, which is nothing but minus mu s n2 sine theta plus mu as cos theta plus n2 cos theta minus mu as sine theta, which is nothing but w. So what will be your n2 over here using these equations? N2 over here, n1 is this, n2 can be written as w by, so cos theta minus mu as sine theta, and one minus will come from here again, so this will become plus sine theta, and then minus mu as square cos theta. Okay, mu as square cos theta. So this is what will be your answer for n2. What will be your n1? N1 will be times sine theta plus mu as cos theta divided by sine theta minus mu as square cos theta, like this. So your n1 and n2 both are now computed from the FBD of A. Now we have to utilize this relationship. So if we write down again summation of Fy equals to 0. So if we use Fy theta, so what will be again theta? That write this particular thing. Let us consider this wedge is weightless. In that case, so wedge is weightless. So summation of Fy will give you n3 is equal to n2 cos theta, and this one will give you this and this. Mu as n2 mu as, this is F2, so F2 is nothing but mu as, so this will become minus mu as n2 cos, and that will be sine theta. Okay, because n3 and F directions are positive, so it means that your n3 is again mu as cos theta minus mu as sine theta times n. What is n2? Here. Okay. So this way you can find out your n3. But what will be f3? F3 is nothing but mu as times n3. Okay. So this way it computes the reaction force, this friction force F3. Now we have to compute this input P. So to compute this input, let us take that particular equation again and write that block again and write Fx is equal to 0 for block B or wedge B. So in this case you will see that you will have P minus F3 minus, so both of the components which are coming, they are opposite to this, so this will be your F2 cos theta and then n2 sin theta, n2 sin theta. Now if you just put the values over here, this is nothing but mu as n2 and F3 is nothing but as n3. Okay, all of them should be equals to 0. It means that P is nothing but mu s and 3 plus mu s and 2. So I can just take this one common. So this will be mu s cos theta plus sin theta and 2. This is what will be your input force to start raising this particular block. So what is your N3? N3 is nothing but this one, and N2 is nothing but this one. You get the relationship.